Good morning. Today we're going to learn about the trigonometry of a right triangle. This is actually a review. You learned about this before. You studied this last year in geometry. Okay, so we're going to start with a right triangle and notice how it's labeled. Over here is we're going to label one of the acute angles as theta. Theta is a common variable used to recognize the measure of an angle. And the sides forming that angle would be the hypotenuse, and then we call this the adjacent side. And then as you can see, if you went right across, that would be the opposite side. Okay? And of course the hypotenuse is always opposite the right angle of the triangle. So we're going to study now the 6 trigonometric functions that shows us what the ratio is of these angles. So again, theta is going to be the measure of the acute angle of the right triangle. And you have sine, which is opposite over hypotenuse, cosine of theta, adjacent over hypotenuse, and tangent of theta, which is opposite over hypotenuse. And if you recall, we used to use the SOHCAHTOA to help us remember. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And down here below them is what we call the reciprocal functions, or cofunctions sometimes also called. This is cosecant, okay, cosecant, and that's hypotenuse over opposite. It's the reciprocal of sine. This is secant, it's the opposite of cosine. I'm sorry, not opposite, reciprocal. And cotangent is the reciprocal of tangent. Okay, abbreviations often used. And again, these are reciprocal functions. See, just flip them upside down. Reciprocal functions. Okay, so when we want to evaluate the 6 trigonometric functions, we need to get all 3 sides. So if we have here the legs are 5 and 12, use the Pythagorean theorem to find the hypotenuse. You should recognize that 5, 12, 13 is a Pythagorean triple. So when we go through, in this particular diagram, this is labeled as theta. So the 12 is the opposite, the 5 is the adjacent, and the 13 is the hypotenuse. And so that's where we get sine is 12 over 13, cosine 5 over 13, and tangent is 12 over 5. Cosecant is the reciprocal sign, so just flip. Secant is the reciprocal of cosine, flip. And cotangent is the reciprocal of tangent. Again, just flip them over. So here's a practice problem about an example of how to come up with the 6 trigonometric functions. Okay, so in this case, if you're given the side 4 and 7 and you had to find the other side, you can still use the Pythagorean theorem. You would know that 4 squared plus x squared, if you would, equals 7 squared, and you would solve and you get the square root of 13. And then same procedure. Okay, here's theta here. Opposite is 4 over 7. So sine is 4 over 7. And then its reciprocal is cosecant, 7 over 4. All right. So pause here and take a look at these examples and make sure you can follow them. Okay. I want you to pause and I want you to try to do these problems. We're going to start with 3 because it's the hardest one, and then you can come back and try the others. So here in 3, notice this is the hypotenuse. It's opposite the right angle. Theta, this was the acute angle labeled. So this is adjacent, and you have to find this side. So see if you can do it, and then list the 6 trigonometric functions. Pause now and try. Okay, so we're going to go to the next page and we find that the opposite side is 5. So this is what we call an isosceles right triangle. This is 5, this is 5, this is 5 radical 2. You might remember from geometry, this is also called a 45, 45, 90. I know if these two sides are 5, and then the base angles have to be congruent. Since this is 90, that means the other two have to add up to 90. Okay, that's an isosceles right triangle. And so these are your trig functions. Pause now and check your answers. Okay, I'm sorry, I'm going to go back now, and we're going to take a look and try these other, try number 1 and number 3, and then check your answers. Pause and check your answers. Okay, we're going to try number 4 now. Here they just give you one trig function, 7 and 10, and you have to evaluate the other 5. So if you draw the triangle and leave adjacent and hypotenuse is 7, 10, then use the trig functions to get the other numbers. Pause and check your work here. Sorry, I'm going to go back and also check your answer here. Okay. All right, again, this is a reminder from algebra. You did this in geometry. We looked at special right triangles. This is the 45, 45, 90 triangle. This is one, this is one. You can use the Pythagorean theorem and you'll find out this is square root of 2. This is a 30, 60, 90 triangle. Call it half of an equilateral triangle. So if the smallest side is 1, the hypotenuse is 3, and the leg is the square root of 3. Pause now and check to see that the Pythagorean theorem works for these two triangles. Okay, so now we can memorize these special ratios. So forget for 30, okay, the sign is opposite over hypotenuse. That's where you get the 1/2. Pause now and follow this table. Now, for some of these, such as the 45-degree angle, when you get opposite is 1 over square root of 2, these are rationalized. The numerator and the denominator was multiplied by the square root of 2 and simplified. Try seeing if you can get these numbers and simplify. Pause now and try that. Okay, so here's an example where you're giving one angle, and it's one of the special right triangles. So this is 30, that would be 60, and that's 90. Okay, so now remember the ratio. The smallest side would be 1, 2, square root of 3. So this is not 2, it's 8, so this must be 4. 4, 8, 4 radical 3. That's the ratio. Okay, take a look at this work. You know the ratio is square root of 3 over 2 equals x over 8, and you simplify and solve. And this is using, again, the special right triangle rules. Okay, square root of the cosine of 30 is square root of 3 over 2. The adjacent is x over 8. You're using that ratio. Okay, so I'm going to stop here and I'm going to assign some questions from the textbook. This question number 11 I'm going to do with you, and then you're going to do some on your own. Okay, so this was telling me you're going to let theta be the acute angle of a right triangle, and you're going to have two trig functions, tangent and secant, and you're going to sketch the triangle. Now let's start with tangent. So I made the right triangle. Okay, label this theta. Tangent is opposite over adjacent. So This must be 4 over 9. Now, it might not be exactly 4. This could be 4x over 9x, but I know the ratio is 4 over 9. Okay. Secant, remember, is the reciprocal of cosine. Okay, so that would be adjacent over hypotenuse. 9/49. See? I took the reciprocal, and I realized this is the adjacent, that's the hypotenuse. Now you could have really have done this with just knowing tangent, because you could have used the Pythagorean theorem. And now evaluate the 4 other trig functions. Okay, so we're going to come here to exercises. You're going to, at this point, you can stop the video after you write down your homework. So you're going to do these 6 questions, 5 through 10, and you're going to do the odd questions, 13, 17, okay, just those two, 13 and 17, and well, actually, let's throw another one in, 13, 17, and 16. Okay, that's your homework, and have a good day. Oops.